Matrices, adding, subtracting, and multiplying matrices. Alright, so for today we're talking about matrices, so the first question becomes, what is the matrix? Now, as we all know, The Matrix is the science fiction film released I'm sorry, this is the wrong presentation. Our question is, what is a matrix? So, the answer to that is, a matrix is a rectangular array of numbers. Now, within the matrix, we have many elements. An element of a matrix is one of the numbers in the matrix. And finally, the dimensions of a matrix tell us how many rows and columns it has. So, we're now going to try this out. We are going to write the dimensions of each matrix and identify the given element. So, here's our first matrix: 7, -4, 3, and 12. Now, as I said, a matrix is made up of rows and columns. So in this case, there are 2 rows and 2 columns. So this is a 2 by 2 matrix. I'm going to rewrite that. 2 by 2 matrix. Now, in this case, I am looking for row 2, so not row 1, but row 2, and then column 1, which means that my answer to A2, 1 would be 3. Let's try that again just to make sure that we understand it. So in this case, this is a 1 row by 3 columns. So this would be a 1 by 3 matrix. And A1, 2 would be row 1, column 2, or 9. We have one more that we're going to try. In this case, this would be a 3 row by 2 column matrices, so a 3 by 2. And A3, 2 would be row 3, column 2, or 4. Now, when adding or subtracting matrices, the matrices have to be the exact same size, meaning the same number of rows and the same number of columns. So, we are now going to find each sum or difference. Let's start with this. So, what we do is we find the equivalent parts. So 2 will go with 0, -4 with 7, 3 with -2, and so on and so forth. So 2 plus 0 is 2, -4 plus 7 is 3, 3 minus 2 is 1, 0 plus 13 on our next row is going to be 13, 1 plus -1 is 0, and 12 plus 5 is 17. Here, we have to do one thing before we can go on. Notice that this matrix is being multiplied by 2. So, 2 times 6 is 12, 2 times 5 is 10, 2 times 10 is 20, and 2 times 0 remains 0. And now we will be still subtracting it by -4, 3, 0, -1. So 12 minus -4 actually becomes positive 16, because remember, when you subtract a negative, it becomes positive. 10 minus 3 is 7, 20 minus 0 is 20, and 0 minus -1 becomes positive 1. Alright, now that we've done that, we're going to solve each matrix equation using addition or subtraction. So here we have x minus this matrix right here is equal to this matrix on this side. Now notice these are both 3 by 2 matrices. So I will solve this just like I would any algebraic equation by adding the thing that I'm subtracting from x, meaning plus 2, 0, 5, 1, negative 4, 3, which will cancel this out, meaning 5 plus 2 is 7, 7 plus 1 is 8, 2 plus 0 is 2, 13 minus 4 ends up being 9, negative 12 plus 5 is negative 7, and 0 plus 3 is 3. So that would be our answer. Now let's try this. We want to find the value of each variable. Now when we have variables, just remember, A is the equivalent spot as 5, 2B is negative 7, and so on and so forth. So I can already say that A equals 5. But now we need to solve. So I know that 2B equals negative 7, which means 2B may be negative 7, but our answer is not 2B. So I divide by 2. B equals negative 3.5. Now I'm going to solve for C. Now we know that C minus 2 equals 10, so I would add 2. C equals 12. And finally, I'm going to solve for D. D plus 3 equals 10, subtracting 3, D equals 7. Now that I've done these, we're going to convert each of these systems of equations into a matrix equation and then solve them using an inverse matrix and the calculator. So the first thing we have to do is convert these systems into a matrix, and then we're going to go into the magical calculator. Ooh, amazing! Now we have to convert this system into a matrix. So what we do is we look, and everywhere that we see a variable, we have a coefficient. Now remember, if we see no coefficient, that coefficient is either 1, or if we're subtracting, negative 1. So let's write our original 3 by 3 matrix that we would be writing. So in this case, 1, the negative y becomes negative 1, the negative z becomes negative 1. On the second row, 3x becomes 3, y becomes 1, and then 2z becomes 2. X becomes 1, y becomes negative 1, and z becomes 2. Now we have a second matrix in this case, which would be x, y, and z. Oh, that is a horrible z. And z. And if we were to multiply these, we would end up getting this system of equations. And all of this is going to be equal to negative 9, 12, 0. So the way that we end up having to do this is we will have to find the inverse of this matrix and multiply it of this 3 by 3 matrix and multiply it by this. And for that, we have to go to the calculator. Now for this next part, we're actually going to need to use a calculator. But the thing is, I don't really want to be in this video. So rather than use this calculator, I'm going to just be mirroring an app that does exactly the same things. So the way that we're going to use the calculator is the first thing you have to press is the second key and then the inverse key, which says matrix in yellow. You will be given a menu that looks something like this, perhaps a little different, and then you will want to go over to edit. And we are going to take our first equation. In this case, here's our matrix, and we need to say the number of rows, 3, the number of columns, 3. At which point, I have to start inputting my data. So remember, it was 1, negative 1, negative 1. 3, 1, 2, 1, negative 1, 2. Now I'm going to press second and quit and go back to the matrix menu, edit, and create a second column, just like I did before. This one is going to be 3 columns, rows, by 1 column. And that was -9, 12, and 0. So once we've created both of those columns, what we have to do is we have to press second matrix, choose column A, and then press that same button but without the second so that we get an inverse. Then I'm going to press second matrix again and choose column B and press enter. And our final answer is x equals 0, y equals 6, and z equals 3. And that is how you solve matrices with your graphing calculator.